College Algebra 3.5, Rational Functions. This is 3.5a. We may have a B, C, D, E, and F. Who knows? This is a pretty long section, and it gets into some pretty big detail. So anyway, we'll try to get through this painlessly as possible. First sentence on page 300 says, now we turn our attention to functions that represent the quotient of two polynomials. Okay. Whereas the sum, difference, or product of two polynomials is a polynomial, so if we add two polynomials, we subtract, or we multiply two polynomials, we get for our answer a polynomial. But when we take the quotient of two polynomials, it is not necessarily going to give us an answer that's a polynomial. So, what we're going to do is we're going to look at rational functions. And a rational function is formed by dividing two polynomials and getting a quotient. That quotient then is a rational function. So if you look at the top of page 301, it gives you some examples of rational functions, what the graphs look like. Some of them are pretty scary. But for the most part, we're going to just take this one little piece at a time. So if you look down at the bottom of page 301, it gives us an example of the function of x equals 1 over x minus 3. Alright, so it says find the domain and then graph f. So actually all it's asking you to do is find out what number can we put in there for x to make this 0. Or what number can we put in there for x that will make this fraction undefined. And we've been doing this all along, and you find out very quickly, very easily, that x has to be 3 in order to make this undefined. So the domain of this, written in interval notation, would be all numbers from negative infinity to 3, not including 3, as well as not including 3 and going all the way to positive infinity. So that's interval notation of the answer there. Or if you did set builder notation, you'd get something really easy like that. Okay, x such that x is not 3. Okay, so if I gave you a whole bunch of different problems to determine, so for example, if you look on page 303, you can see some different functions over here, and what we're interested in is the domain. So the domain here would be all numbers except 0, all numbers except 0. What can this not be? Well, if you factor this down, it would give you x plus 2 and x minus 1, so x cannot be negative 2, cannot be 1, which we showed here in set builder notation. And remember interval notation right here. You've got 3 different intervals. The numbers less than negative 2, the numbers from negative 2 to 1, and the numbers from 1 to infinity, because the only numbers that don't work are negative 2 and 1. So that gives us 3 intervals that we're looking for. Below negative 2, between negative 2 and 1, and above 1. And we do the same thing here. We factor this down, just the numerator. We don't care about just the denominator. We don't care about the numerator. So 2, x minus 3, therefore x cannot be 3. In this one, again, we factor it down. X can't be negative 1 or positive 2. And right here, x cannot be negative 1. So just real quick and easily, that's what the breaks are. That's what the places in the function that x cannot be. And one of those things that's important is those places where x cannot be are called the asymptotes. So asymptote is the main heading on page 303 in the middle of the page. Alright, so it says look at the graph f of x equals 1 over x minus 3. So let's look at that graph. Notice what happens here. As we approach 3 from this direction, what happens to my y value? my y value gets bigger and bigger and bigger all the way to infinity. One of the things that's important, though, is that this graph right here never gets to this vertical line here at x equals 3. Never gets there. It goes into infinity and it gets closer and closer and closer to 3, but it can't get to 3 because if it got to 3, x would be 3 and it would make this undefined. So, since it can't be undefined, it can't ever get to the 3. And if the number were to start here and get smaller and smaller and smaller and approach 3, as it approaches 3, the y value gets bigger and bigger and bigger. So, as this number on the bottom gets smaller, the y value gets bigger and bigger and bigger, all the way into infinity. In fact, it gets closer. I mean, it'll be as it 3.00000000001. I mean, it'll just keep getting closer and closer to 3, but it'll never actually get there. As we approach it this way, we'll get 2.999999, and this will just keep going down further and further and further, but it will never cross this line here. And that line then is called an asymptote. A vertical asymptote is what that's called. So, as we approach 3 from this direction, we are approaching 3 from the negative direction. As we come from over here, we are approaching 3 from the positive direction. Now we're going in a negative direction. We're getting smaller and smaller and smaller, and eventually we'll be over here in the negatives. So going from right to left is going a negative direction. But what we're saying is we are approaching 3 from a negative direction. We're approaching 3 from a positive direction. So what we say here, or how we write it, is f of x approaches negative infinity as x approaches 3 from the negative side. So, what that says is, my y value, this value right here, up and down, it will approach negative infinity, see how it's going more and more into negative, as x approaches 3 from the negative direction. So as x gets closer and closer to 3 from the minus or the negative direction, the left-hand side, my y value becomes more and more negative, all the way to infinity. This part here says, as my f of x approaches positive infinity, so it's getting bigger and bigger and bigger, and it will go into infinity. So as it's approaching positive infinity, as x approaches 3 from the positive side. So that would be written, this part here, f of x approaches positive infinity as x approaches 3 from the positive direction. Okay, so I'll let that sink in for a second. So if you look at bottom of page 304 where it says determining asymptotes, what we've got here is in that purple, it tells you how you determine an asymptote, a vertical asymptote. It says for a rational function, f of x equals p of x over q of x. So it's given us a function, and if it says if we have a polynomial on top and a polynomial on bottom, if a is a 0 of the denominator, then the line x equals a is a vertical asymptote. So what it's saying here is if we can find out what the zeros are, or we can find out what makes the denominator undefined, that will tell us what our asymptotes are. So all we have to do with that is take 2x minus 11, and again, we don't care about the numerator, and we factor this down, so you always factor it, and it factors to x plus 4 and x minus 2. So what makes this undefined? When x is negative 4 or x is 2. So there's my asymptotes. So if I were to draw my graph here, my asymptote would be here through 2 and through here. So that means I've got a graph. When I graph it, which we're not going to do right now, but at least show you what the graph looks like. The graph would look like that, and like that. So notice it never crosses the red vertical line here, nor does it ever cross this line. So we've got part of our graph here, part of it here, and part of it here. And later on you'll learn how to graph those, but right now that's what we've got. That's pretty much all there is to finding the vertical asymptote. Should not be too difficult there. Okay, so let's erase that and look at B. B gives me my function g of x equals x minus 2, bottom of page 304, x cubed minus 5x. So all we're looking at is the denominator. Factor out an x and we get x squared minus 5. And we keep going here. X is equal to 0 if we plug it in there. Or x squared equals 5. X equals plus or minus the square root of 5. So I get 3 answers here. I get a graph that I know crosses at 0. So let's do a red line here, or an asymptote at 0. And I also get an asymptote at the square root of 5, wherever that is, a little bigger than 2, and negative square root of 5. Okay, and they give us a graph here, which again I'm not expecting you to be able to do right now. Sorry, that does not cross, that's just a bad graph, like that. And then it gives you another graph that kind of goes like that, and then another part of the graph that goes like that, and then another part that goes this way. So the graph can get pretty crazy when you get into see some of these polynomials with huge exponents as a leading exponent, or the degree of the polynomial. So we're not going to worry about doing the graph. I just want you to be aware of the idea of what the vertical asymptote is and how many there are. Okay, so that will take us into horizontal asymptotes, which will be the next video, 3.5b.